Hi guys, my name is Peter C. Dr. Junior, mathematics instructor at the University of Liberia and your math tutor. In my today's lesson, I will be discussing matrix algebra, and under matrix algebra, we will be looking at finding transpose and also finding the product of two matrices. So in the previous problem, we found the determinant of two matrices. So in this problem, we want to find the transpose and then finding the product of these two matrices. So as you can see, question B says J raised to the power T means J transpose. This means matrix J transpose and multiply by matrix A. So the first thing we need to find is what is our J transpose. So we first need to know what is our J transpose. What is that matrix? So to find J transpose, we look first for J. What is the matrix J? This matrix J, 1, 2, 3. That is, you have row 1, row 2, row 3. Now, to find a transpose of a matrix, this is row 1, row 2, and row 3. And then this one is column 1. So to find the transpose of a matrix is just very, very simple. Change the rows to column and the column to rows. That's all. So this is a column, right? This is a column. So I'm going to write this column as writing a row. So instead of it being like 1, 1, 1, I'm going to write it like 1, 1, 1. So if you clearly see, in this matrix we have 3 rows, 1, 2, 3. So it's 3 rows. Remember, rows come first. 3 rows and then 1 column. So it's 3 by 1. So it's 3 by 1. That's the dimension of this matrix, 3 by 1. So now if you look here, you have 1 row. And then you have 1, 2, 3. 3 columns. So it's like 1 row, 3 columns, 1 by 3. So we have transposed this matrix. It was 3 by 1 row by column. So we have changed it now to 1 by 3. That's how we transpose any given matrix. For example, if you're asked to transpose D transpose would just be this row 2 minus 1, I'm changing it to column 2 minus 1, or even this column 2 minus 1, I can change it to row 2 and minus 1. It's still the same. So I change this row to column, I change this row down here as well to column. So it's the same. If I want to find the transpose of this matrix, I'm going to do the same. C transpose will now give me this row. I change it to column, so 2 minus 2 and 9. This second row I change it to column, so it's 0, 3, and 1. This third row I change it to column 1, 7, and 5. It's the same as saying this first column I change it to row 2, 0, 1, 2, 0, 1. The second column, I can change it to row minus 2, 3, and minus 7, and so forth. So that's how we change, we transpose a matrix. Okay. So let's now move to what the problem tells us to do. The problem says we must find J transpose times A. So for for two matrices to be multiplied, J transpose times matrix E. So J is 1, 1, 1. And then what is matrix E? Matrix A is 3, 2, 2, 5, minus 1, 4, 2, 3, 4. Now, like the way we said in adding two matrices, the rows must be the same as the rows in the second matrix. The column in this first matrix should be the same as the column in the second matrix in terms of their number. But for multiplication, now this is 1 by 3, and this is 3 by 3, right? So in order for you to be able to multiply two matrices, the column of the first matrix and the row of the second must be the same. The column of the first matrix and the row of the second matrix must be the same. Then the row of the first matrix and the column of the second matrix will be the dimension of the new matrix, or the dimension of the product of the two matrices. So the dimension of this new matrix now is going to be 1 by 3. So if we multiply these two matrices, the result we're going to get is going to be a 1 by 3 matrix, most times in this form. So if you have J sub JT times A, it is going to be in the form of some A1, 1, A1, 2, A1, 3. And now let me explain this. This means, in terms of the this multiplication now, this means row 1 multiplied by column 1, row 1 multiplied by column 2, row 1 multiplied by column 3. That's exactly what it means. So there's row 1 multiplied by column 1. That's what we're going to do in the first area. So row 1 multiplied by column 1 is going to be 1 times 3 is 3, plus 1 times 5 is 5, plus 1 times 2 is 2. So this entire expression is just going to be like a term within, or an element within the matrix. Then we'll move to the second one. Row 1 again times column 2. So it's 1 times 2. So you leave space. So it's 1 times 2 is 2, plus 1 times minus 1 is now minus 1, plus 1 times 3 is 3. Then you leave little space again. Column 1 again times column 3. Row 1 times column 3. So it's 1 times 2, 2. 1 times 4 is 4. And 1 times 4 again is 4. So we simplify now. We just have 3 plus 5 plus 2 is 10. So this is 10. Please don't put comma. No, don't put comma. Just leave space. 2 minus 1 is 1. This is 4. And then 4 plus 4 is 8, plus 2 is 10. So the multiplication of J transpose times A is just equal to 10, 4, and 10. If you were to just say J, instead of finding the transpose first, you just went straight to multiplying matrix J by matrix A. Matrix J has 3 by 1 dimension. Matrix A has 3 by 3 dimension. So if you clearly look at the technique, the column of matrix J is not equal to the row of matrix A. Therefore, you cannot multiply matrix J and matrix A, wherein matrix J will come first. What if matrix A had come first? A times J. What if A had come first? So it's 3 by 3. And then for matrix J now is 3, because 1, 2, 3 by 1. Matrix A can be multiplied by matrix J when matrix A is first. The resulting matrix would just be a 3-row and 1 column matrix. So this is it for finding the transpose of a matrix and multiplying matrices. So thanks ever so much for watching. See you next video.